This video is about transformation of functions, and so if you can disregard everything below that red dot on the left, we're only going to deal with that equation on the left, right here, this red dot. And these are the things that we're going to change so I can describe to you what's happening with transformations of functions. It all works the same. I'm going to work on polynomial functions, but then after that I'm going to probably add a function in below this that is like the square root function, absolute value function, so you can see that it works the same with everything. But right now I have a line. How do I know that this line corresponds to this because of all these crazy numbers? And in fact, let's change this to plus k over here because I think that's what you're going to be used to, though we'll want to shift it over, I think. So right now it's a line. Actually, let's go back the other way. Undo. Right now, since this n is a 1, see I've assigned this n as 1 here. This n is a 1. This is actually the point-slope form of the equation of a line. And one of the reasons why I prefer that over slope-intercept or standard form is because this slope is here. I've labeled it a for now. In the line, we usually put m here. And this h is an x1 and this k is a y1. But this is the point-slope form, where I have y minus a y value from a point equals the slope times the quantity x minus x1. And so this is why I prefer this form. If I were to change n to 2, hopefully you're thinking, what's that going to be? Hopefully you thought, if I change this n to a 2, I will have x minus, I don't care, squared. Right now it's 0, and k is 0, and a is 1. So really I'm going to have y minus 0, which is just y, equals 1 times x minus 0, which is just x, squared. So I really have y equals x squared, which is the parabola y equals x squared. So that's what we have right there. If I change this to 2 to 3 now, I'm going to get, I hope you know, you're going to get the polynomial function y equals x cubed, because I have not changed any of the other numbers. And then if I move it up again, it's going to be y equals x to the 4th, y equals x to the 5th, y equals x to the 6th, y equals x to the 7th. And of course, if you've watched the polynomial functions equation, you know all the odd ones, all the odd exponents result in this one side going up and one side going down. They're opposing each other. And if it's even, for instance 8, they both go up or they will both go down depending on the transformation. But the parent functions look like these guys that I'm rolling through right now. Pow, 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 pow. It gets narrower but wider at the bottom as I increase in power or exponent. Okay? So let's go back to the parabola. Again, as I was saying, you are more used to, and in the textbook, seeing this plus k on the other side, but it doesn't change the function at all. It doesn't change the function at all. It's still the same as it was when we were looking at it previously. So the vertex is hk, and as I said, you can think of it that way, or you can think of it as a transformation. And what I mean by transformation, I mean a shifting of the right to the left, or the left, this or up and down. This h, so I'm going to leave n the same, I'm going to leave a the same, I'm going to leave k the same, and I'm going to change h and watch what happens. So when I change my function to be y equals, what is that? H is 4, x minus 4, quantity squared. Okay, that's what I just changed it to. Let's change the color to green. So that green function is the red function, or what I changed the red function to by changing the h to 4. If I bring this back to 0, I will have no shift. So this 4 shifts the red function to the right to be the green function. And so it's shifting to the right 4 units. Now if I change k to be plus 4, let's make it plus 5 just so it's different. This, if I add a plus 5, also shifts it up. And then of course if I make it match, I make this h a 4, it matches up, they line up, and they're the same function. So what I'm trying to demonstrate, well or not well, is that h represents a shift to the horizontal axis, a shift along the horizontal axis. In this case, I put the number 4 in, so it's a shift to the right 4 units. 1, 2, 3, 4. And this is why I constantly tell you guys, maybe not you, or I'll constantly tell you guys, it's not specific to this particular group, that this minus sign is part of the formula. And this plus sign is also part of the formula, but it doesn't matter, because if I think of it this way instead, minus k over here, minus k over here, then they act in the same way as opposed to this contrary thing where the minus sign is there but not the other one. If we write it this way, which you're not going to see in the textbooks, you're not going to see on the internet for the most part, but if you write it this way, it is going to represent this k is a shift up or down, and this h is a shift right or left. And so if I wanted to shift down 3 units, let's say I wanted to shift the parabola down 3 units, I would change this to a 3. I'm sorry, change it to a negative 3. It's a shift down of 3 units. And I leave the negative sign as part of the formula or equation. So my k value is negative 3, so let's match it up. If I make this negative 3, 1, 2, 3, and then make this h a 4, 1, 2, 3, 4, it matches up. So let's remove this and let's start predicting so we can get a hang of all this. If I wanted to shift this parabola to the right 10 units and down 7 units, what would my h and k values be? Pause. Now that you've unpaused and you've written down your answer, hopefully you've written exactly what I asked. H equals what and k equals what. Hopefully I'll remember the numbers. But then hit pause again and write down what the formula for the parabola would be. Now that you've unpaused, I don't know why I have to wait so long, we're going to make this 10, because that's what I said, a shift to the right 10 units, and down 7 units, if I remember correctly. Oops. Negative 7. So that means my k value was negative 7, and my h value was positive 10. And if I turn this back on, there it is, matched up, red to green. Okay? Typically, the software is going to want you to change this to plus 7, but it acts in the same way, right? Because minus a negative number is plus a number. Okay? So am I making some sense? Now here's the thing. This works whether it's a squared or whether it's a cubic. Oops, I'm going to change this to 3. And so no matter if it's a cubic or not, it still works the same way. Those horizontal and vertical shifts work the same way. Okay, so if I change this to 0 again and change the k to 0 again, if I wanted to shift up 3 units and to the left 5 units, so this is up 3 units and to the left 5 units, that's that. What would my function look like? It would look like this. What did I say? Left 3 units. Oops. Left 5 units, sorry. And then up 3 units. And that's that. That's what my prediction would have been. That's what my equation looks like. They're going to want you to write plus 5, and that's fine. And they may want the written as a function with y by itself and add 3 over to this other side, to the right-hand side. But 6 and 1/2 dozen the other. I'm hoping that from these videos you're getting understandings. The mechanics will come. So it does not matter the power of the polynomial. It'll work the same exact way. Now, what about other functions? So in here I'm going to write down, actually let's leave that there. I'm going to just turn this off. I'm going to write another function in here. Square root function. So y equals, and we probably want to turn this off. We'll come back to that. Y equals SQRT x minus h. We'll put an a here, just like we did before, and minus k. So there's my square root function, but again, it's following my a's and k's and h's up here. So let's make this 0. Let's make this k 0. And so I have this, it's at the origin, and it's my square root function. And so my h's and k's work the same way. And so this kind of comes into play with the same as the, what did I want to say, the domain restrictions on the even root functions. So when I shift this to the left 2 units, I'm getting h minus -2, which is, excuse me, x minus -2, which is x plus 2. So x can be as low as -2. -2 plus 2 is 0, but it can't be any less than that, or else I get that negative number in there as my argument. So that becomes problematic, right? If I shift in the other direction horizontally, the lowest the number can be is 6. Why? Because I have x minus 6. If I put 6 in here, I'll get 6 minus 6, which is 0. If I put 5 in there, I'll get 5 minus 6, which is -1, which I cannot have a function in the real plane that has an argument that's negative, in this case -1, as I described. So that's what's going on with these horizontal and vertical shifts. It's really understanding this h and this k, and it works the same way. If we want to, we can... let's not do that. Let's do the following. We need to talk about another piece of transformation, another type of transformation. It is often called the stretch, and we're going to zero out our translations, the shifting left and right and up and down. We're going to zero out those translations, and we're going to talk about this a value. So watch when I increase this a value to be a number greater than 1. Our curve gets skinnier. It gets skinnier. And if I change this n back to 2, it'll be something you're more familiar with. There's a parabola, and it gets skinnier. And how I think of it is this number a is a multiplier in front of this. It's a multiplier in front of this. And so what we have right now is we have this function with a squared, right? Except we have a multiplier here, and the multiplier is 4.1. And so whatever number I put in for x, it comes out and becomes its normal x squared compared in red, okay? But if I increase this number to be 4.1, it's going to take whatever came out of the x squared and make it 4 times larger. So that means for the value of 1, instead of being 1, 1, I'm going to be 1, 4 times larger than it. Or 5 times larger than it. So notice how the red one's skinnier. If I make this 1, that's my parent function, y equals x squared. And so as I increase, it gets skinnier. If I go to numbers less than 1 but greater than 0, less than 1 but greater than 0, my parabola gets flatter. And I can make it super, super flat. When it's actually the a value is 0, I'm going to get the line y equals 0. Because 0 times x squared, I don't care what x value is, it's going to be 0. But once that a value becomes negative, all of my x squareds, which are going to be positive, all of them are multiplied by a negative number. So they all become negative. So all of these green values that used to be positive, I'm now multiplying by a negative 0.1, so they become negative. So if I actually make this a -1, this is the mirror image of that, because these exact same values coming from y equals x squared are getting multiplied times this -1 and flipping over. They become negative. And then the same thing happens. It gets skinnier when that negative value is increased. Okay? So that's what's happening with transformations, and it works the same no matter the function. Okay? It works the same no matter the function. So hopefully that was short enough. Typically I ramble about this topic because it is one of my favorites and one of those big epiphanies I had when I was doing this math. All right? Hopefully this helps. Ask me lots of questions in class. Bye.